Okay, we were taking an interesting integral. This one was sent to me by Sid. We have the integral of natural log of x to the x to the x plus x to the x plus natural log x plus 1 dx. Okay, to get started with this, I actually found a few different ways to do this one, but all of them were really similar because it all came down to finding out what is the derivative of x to the x. Because that's usually the thing that's kind of tricky, having x in the base and the exponent. And actually, we really have the same thing right over here. And so before I look into that, I think I'm actually going to take this right here and bring it out front, just using log properties and rewriting it so that we have, this in both cases. So we're going to have x to the x times ln x plus this and all this stuff. And then again, I want to know what the derivative of this thing is. We'll do it as a u substitution. I'm not sure how it's going to work yet, but let's just write it this way for now. And then before we take the derivative, I don't really like it in this form. I want to rewrite this. And what we can do for x is we can actually write this like e to the ln x. So if you just plug this back in here for x, we can write our u value as just e to the x ln x. And now we'll just go ahead and take the derivative. It's going to be easier using this form over here. So when we do that, we just get the whole thing back with the base being e. But then we're going to need the chain rule on all this. The derivative of this first, take the derivative of x, that's just going to be 1 times ln x, plus we get the x. Derivative of ln x is going to be 1 over x. But the x's are going to cancel, and this is just a 1. So I'm just going to clean this all up. I'm going to reorder it. So bring it to the front. This is just going to be natural log x plus 1 times this, but I'm going to write it back in this form just as x to the x. But now coming back to our integral, there's a few interesting things. First of all, ln x plus 1, we actually have that right there. And the other thing is, because we have this term in common here, if we factor that out, if we factor out the x to the x, then this is going to become ln x plus 1. So let me just rewrite this in order to set it all up. So we're going to factor out the x to the x. Here we'll have our ln x plus 1, and then we'll just have this stuff over here. The first time I did it, actually, I just separated these terms and integrated it because we know how to integrate natural log x. But that's kind of a cop-out, I think. That's kind of splitting it off is kind of a boring way when we have this other stuff going on, so I'm going to leave it. So now writing it like this, now we actually have this piece right here is du. So if we break this into two integrals, this piece is going to be easy. This piece, like I said before, we know how to do it, but I want to use this. So what I'm going to do is I'm going to split it into two integrals, but we'll manipulate this one in a second. So first we'll have this x to the x ln x plus 1. And then for this second one, what I'm going to do actually, just notice if I multiply in here x to the x, now I've created this du right here, but of course I don't want to change it, so we'll multiply in x to the x in the denominator. But then you'll notice this one's perfectly set up for the u substitution as well now, because we have this right here in the denominator, this is our u, and then we have du in the numerator, so it's just going to be du over u. So I'll go ahead and substitute this. First, this one's just going to be the integral of like 1 du. Sorry, this looks like a du over here. I should have this as a dx. I don't know if that was bad handwriting or what. And now for the second one, the whole numerator is going to be du, and this is just our u value. But now we've got two really simple integrals. We'll go ahead and integrate. Integral of 1, that's just going to be u. And then integral here, this is going to be natural log absolute value of u. And so all we need to do is just back substitute it in order to finish it off. I'm just going to need a little more space. Okay, so now I think we're ready to finish it off. We know our u value is going to be just x to the x. And then here, this is just going to be natural log absolute value of x to the x. Add a plus c, and that's it. Okay, there you have it. Really good integral today. Thanks again to Sid, and thanks everyone for watching. Have a good day.